So this one they ask us to translate this phrase. They tell us let Q represent our number. So we have 2 subtracted from a number. Our number is Q. So 2 subtracted from. So we're taking 2 away. And what are we taking it away from? We're taking it away from Q. So Q is what we're starting with, and then we're taking away 2. Notice that's not the same as 2 minus Q. Here we're taking Q away, but we're asked to take 2 away. Subtract from, 2 subtracted from is the same as saying take 2 away from. So this way, not this way. So take 2 away from Q. And then we have several adding and subtracting problems with signed numbers. Here is, do we add the numbers or subtract? It's easy to see the minus here and want to subtract. But if they're both negative, then we're accumulating negatives. Just like if they're both positives, they're building up, they're adding up. It's only when we have opposite signs that they subtract. They are canceling each other out. We have some here that are to the good, some to the negative, and the good cancels out some of the negative. So when the signs are the same, we add the digits. 7 plus 5 is 12. Take the sign of the larger number. So the larger number is 7 and it's negative. Here, if we have a double sign, we said that we want to fix that. So 2 negatives make a positive. A negative means the opposite of, so the opposite of negative is positive, so we end up with 28 plus 5. The 28 is understood to be positive because there's not a sign in front of it. If they're both positive, they build up, they accumulate. So how much is 28 plus 5? 8 plus 5 is 13. Here your 1. 2 plus 1 is 3. 33, take the sign of the bigger number, so it's positive. Right? Again, we have a double sign. So minus a negative, the opposite of a negative is a positive. So negative 3 plus 11. We have opposite signs here, and anytime we're adding or subtracting and our signs are opposite, they're canceling out, so we subtract. 11 minus 3 is 8. Take the sign of the bigger number. The larger number is positive, so that's positive. This one is similar to the previous one. The opposite of a negative is a positive. So we have minus 2.8 plus 4.1. Since we have opposite signs, we subtract. When we subtract, we always want to write the larger number on top. So 4.1 is the larger number. And when we have decimals, we have to line up the decimal place. So we can't take 8 from 1, so we borrow or we regroup, and we take 3 from, or take a 1 from here, and that makes that an 11. 11 minus 8 is 3. 3 minus 2 is 1. And we take the sign of the larger number. So the larger number is positive, so that's positive. So a lot of it here is about knowing what the rules are. Here we have another adding or subtracting problem. So this one has to do with fractions. So when we have fractions and we're adding or subtracting, we have to have a common denominator. So remember, to get a common denominator, it's what can we multiply this by something and this by something to get that number. What number can we turn this into and turn this into that's the same number? So we can turn these into other numbers by multiplying. So essentially, we're looking for multiples of 10 and multiples of 4 until we find one that a number that's a multiple of each of those. So these are multiples of 10. These are multiples of 12. Notice when we get from, instead of 12, of 4, I was writing 12. These are multiples of 4. So 20 is a common multiple. So we're going to rewrite each fraction with a 20 on it. Notice we keep the sign that goes with our fraction. So to make the first fraction have a 20 on bottom, 20 is 10 times 2. So we have to multiply top and bottom by 2. 1 times 2 is 2. To turn this fraction into having a 20 on bottom, 20 is 4 times 5, so multiply top and bottom by 5. So 7 times 5 is 35, and then we have 20 on bottom. So we keep our denominator, and then we put our numerators together. So we have a minus 2 and a minus 35. These have the same sign, so they're building up, they're accumulating, they're adding. So 35 and 2 more. Well, 2 more than 35 is 37. Take the sign of the bigger number, which is negative. That fraction doesn't reduce, so we leave it just like it is. So let's take a quick moment to see why can we multiply top and bottom by 2 or top and bottom by 5 and this fraction still be the same amount as that. Well, keep in mind that anything over itself makes 1. So really all we're doing here is multiplying 7 over 4 times 1. Even though it looks different than 1, if it's the same number on top and bottom, that's equivalent to 1. Anything times 1 is itself. So when we multiply 7 over 4 times this fraction, this is the same as itself. It looks differently, but because of what we multiplied by, it's equivalent. Same thing here. 2 divided by 2 is 1. If we multiply this fraction by 1, we get the same amount. It just looks differently. So getting that common multiple, that common denominator, and then what do we need to multiply the denominator and numerator by so that our denominators match? Once we get a common denominator, put them together and use our rules for adding and subtracting signed numbers to get our numerator combined. All right, they want us to write this into an expression and then to simplify it. So this is similar to the very first question we did, except this doesn't have a variable. We're subtracting this from this. So negative 3 is what we start with, and we're subtracting, so minus, and what we're taking away is negative also. So I'm going to put parentheses around it. So this is negative 3 minus or subtract negative 9. So we're subtracting a negative. So easy to leave one of those negatives off, but we have to have both of them. So we have a double sign in the middle. Minus a negative makes a positive, because the opposite of a negative is positive. These two numbers have different signs, so if they have different signs, we subtract. 9 minus 3 is 6. If we take the sign of the larger, it is positive. Now they give us one that just has more than one term, and we're to combine these. So if we think about Aunt Sally, when we have adding and subtracting, we just go left to right. Now, we can get away without going exactly left to right as long as we're careful with what our signs are. But probably to begin with, one of the easiest things is just going left to right. Let's take care of this double sign first. So let's rewrite this. It's 13 minus 15. Positive times negative makes a negative. And then we can go straight across. So when we put these two together, Those have different signs, so we subtract them. 15 minus 13 is 2. Take the sign of the bigger one. And then bring everything else down. Now, do this. These have the same signs, so we add them. 2 plus 8 is 10. Take the sign of the bigger. I know it's tempting to want to subtract because you see the minus there, but if they're the same signs, then they're accumulating. They're building up. The negatives, we're getting more and more and more negative. So to get more and more, we add. So same signs, add the digits, take the sign of the bigger. Same thing here. These have the same sign, so we add 10 plus 7. 10 plus 7 is 17. Take the sign of the bigger number, bring down. And then lastly, these two have the same signs, so add those. 7 plus 5 is 12. Carry your 1. That makes it 2. Take the sign of the larger. And we've combined those. So we've gone all the way down to the end. Another order of operation, and it may have signed numbers as well. So if we look at, please excuse my dear Aunt Sally, we do have something inside parentheses. So on the inside of parentheses, 6 minus 2 is 4. Just like it is. So leave it in the parentheses to simplify what's on the inside. Bring down the 4, 7 minus 2. Now we have to use order of operation again. We have subtraction here, and we have multiplication here. Well, multiplying comes before subtract. So negative times positive is negative. 2 times 4 is 8. And the last operation is to subtract. Remember, 7 is understood to be positive if there's no sign there. So with opposite signs, we subtract the numbers, take the sign of the bigger number.